Hi, hello, welcome to Subhadas's Academy. Today we are going to discuss exam purpose 5 marks important questions. Just 5 marks important questions in one shot. So, you 20 questions 20 marks ತೊಗೊಂಬರ್ತಾವೆ. ಇದ್ರ ಬಗ್ಗೆ ನೀವು ನಿಮಗೆ 4 ಕ್ವಶನ್ ಪರ್ಫೆಕ್ಟ್ ಟೈಮ್ ಮಾಡ್ತೀರಿ. ಸೊ ವಿಡಿಯೋ ಮಿಸ್ ಮಾಡಬೇಡ್ರಿ, ಶೇರ್ ಮಾಡ್ರಿ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸಿಗೂ. ಎಲ್ಲರೂ ಚಲೋ ಮಾರ್ಕ್ಸ್ ತೊಗೊಂಡ ಪಾಸ್ ಆಗ್ರಿ. ಸೊ ಈ ಸಲ ಏನಿದ್ರು 100% ಮ್ಯಾಥ್ಸ್ ಒಳಗ ಸ್ಕೋರ್ ಮಾಡೋನು. ಸೊ ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದಿ 5 marks ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್. ಇನ್ನೂವರೆಗೆ ಯಾರು ಸುಬೇದಾರ್ ಸರ್ಸ್ ಚಾನೆಲ್ಸಿಗೆ ಅಕಾಡೆಮಿಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿಲ್ಲ, ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ರಿ. ವಿಡಿಯೋ ಕಂಪ್ಲೀಟ್ ನೋಡ್ರಿ. ಪ್ರೀವಿಯಸ್ ಒಳಗು ಚಾಪ್ಟರ್ ವೈಸ್ ವಿಡಿಯೋಸ್ ಅದಾವು, ಅವನು ಗೋ ಥ್ರೂ ಮಾಡ್ರಿ. ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದಿ ಕ್ವಶನ್. ಸೊ ಫಸ್ಟ್ ಕ್ವಶನ್ 5 marks ರಿಲೇಷನ್ಸ್ ಅಂಡ್ ಫಂಕ್ಷನ್ಸ್. ರಿಲೇಷನ್ಸ್ ಅಂಡ್ ಫಂಕ್ಷನ್ ಮೇಲೆ ಒಂದು ಕ್ವಶನ್ ಬರುತ್ತೆ, ಅದು ಫಿಕ್ಸ್ ಆಗಿರ್ತೈತಿ. ಬಟ್ ಆದ್ರೂ ಈ ಟೈಮ್ ಪ್ಯಾಟರ್ನ್ ಚೇಂಜ್ ಆಗಿದ್ದಕ್ಕೆ ಡಿಫರೆಂಟ್ ಕ್ವಶನ್ಸ್ ಬರೋ ಚಾನ್ಸಸ್ ಐತಿ. ಸೊ ಔಟ್ ಆಫ್ ದಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಚೂಸ್ ಫ್ಯೂ more examples from the given chapter. Here I have chosen one example. Let a equal to r minus singleton 3 and b equal to r minus singleton 1. Consider the function f from a to b. The function is from a to b is defined by the function f of x is equal to x minus 2 divided by x minus 3. Here the question is, the given function is 1 1 and on 2. Justify your answer. If it is 1 1, why you are saying this one is 1 1? If not, why it is not 1? We have to show them, right? Justify. So solution 5 marks important. Okay, here given is a function f from a to b, where a is equal to r minus singleton 3 and b is equal to r minus singleton 1. And also function is defined by f of x is equal to x minus 2 divided by x minus 3. To show f is 1 1 and f is on 2, we have to follow the definition. That is f is 1 1. f is 1 1 prove ಮಾಡಬೇಕಂದ್ರೆ ಏನು ಮಾಡಬೇಕು? Consider image, that is f of x1 is equal to f of x2. What is the f of x here? X minus 2 divided by x minus 3. Then f of x1 can also be written as x1 minus 2 divided by x1 minus 3 is equal to x2 minus 2 divided by x2 minus 3. Because in place of x here we have x1, substitute x in place of x1. Similarly x2 minus 3 divided by x2 minus 2 divided by x2 minus 3. Now cross multiply, we get x1 minus 2 into x2 minus 3 is equal to x2 minus 2 into x1 minus 3. Now remove the bracket. Here we are going to get here x1 into x2 x2 minus 3x1 minus 2x2 minus into minus plus 2 3 is 6. This is LHS part, and RHS part is here x1 x2 minus 3x2 minus 2x1 plus 6. Here this implies here plus x1 x2 minus plus x1 x2, both sides LHS RHS get cancelled. Similarly 6 6, and in the RHS part in the LHS part we have 3x1 minus 2x2 is equal to minus 3x2 minus 2x1 in LHS part, RHS part, right? Take this minus 3x1 to x2 to LHS and minus 3x1 to RHS. We get it becomes positive, that is 3x2 minus 2x2 is equal to 3x1 minus 2x1. ಅಂದ್ರೆ x1 one term ಒಂದ್ ಕಡೆ ಮಾಡ್ಕೊಡ್ರಿ, x2 one term ಒಂದ್ ಕಡೆ ಮಾಡ್ಕೊಡ್ರಿ. Then we get here 3x2 minus x2 is equal to 1x2 and here 1x1. So here we have considered the function is if f of x1 equal to f of x2, then we have x1 is equal to x2. So therefore we say that f is 1 1. What about on 2? To show that f is on 2, Let us consider y is equal to f of x, the function definition, right? And here we know that f of x is given, that is x minus 2 divided by x minus 3. Now solve this equation for x. We get, take this one this side, cross multiply, we get x minus 3 is equal to x minus 2, right? Y into x minus 3 is equal to x minus 2. Now remove the bracket here in the LHS part. Xy minus 3y is equal to x minus 2. Take x terms one side, okay? So we get, take minus 2 to RHS side, we get minus 2 becomes plus 2 minus 3y is equal to x into bracket, sorry, take this one to this side, minus xy, right? Here we have 2 minus 3y, in this 2 we have x is common, x into 1 minus y, so that is, solve for x is equal to 2 minus 3y divided by 1 minus y, or 3y minus 2 divided by y minus 1. Numerator minus outside to order, denominator minus outside to order, both get cancelled. We remains with 3 minus 2 divided by y minus 1. Both are same, right? So therefore, but here given is a r minus of singleton 1. Why? Because here denominator part, whenever it is equal to 1, y equal to 1, then it is going to define undefined, right? So therefore, our answer is true. So therefore, f is on 2. So which is a required solution. In case of question hoga, the given function is 1 1 or on 2. 1 1 aito illo ant kyar is 1 1 and on 2. Justify your answer andra, this is the solution. Go through this one. Second question, state whether the function is 1 1 on 2, 1 1 on 2 or bijective. If the function is 1 1 and on 2, then that function is called bijective. Justify your answer. Then what is the function? Here function is defined by f from r to r is defined by f of x is equal to 3 minus 4x. Same steps 1 1 and on 2. Okay. Here solution given. First write down given. Given function is f from r to r is defined by, given function is f of x is equal to 3 minus 4x. ಏನು ಹೇಳಿದಾರೆ ಅವರು? f is 1 1 ಪ್ರೂವ್ ಮಾಡಬೇಕು, right? So let f of x1 is equal to f of x2. Then what is f of x1 here? Function is 3 minus 4x, that is 3 minus 4x1 is equal to f of x2, that is 3 minus 4x2. Just replace x by x1 and x2, right? Here plus 3 get cancelled. We remains with 4x1 is equal to minus 4x2. Minus 4 get cancelled. We remains with only x1 is equal to x2. So therefore f is 1 1. Howda? Now we have to show that whether function is on 2 or not, right? To show that again f is on 2, again we have to consider y is equal to f of x. What is f of x here? 3 minus 4x, right? So substitute one. Now solve for x. We get, take minus 4x to LHS, that becomes positive, plus 4x, 3 as it is. Take this y to RHS, minus 3y. Then x is equal to 3 minus y divided by 4. Now substitute whatever the value of y here. We are going to get the value of x, which is also belongs to here R only, domain only. So therefore write it here belongs to R. So therefore f is on 2. ಏನಾಯ್ತು ಈಗ function, since f is 1 1 and on 2, then f is also called bijective function, right? So note it down, very very important. Third question, state whether the function, same function, same question, 1 1 on 2 or bijective. We have to show that the given function only change here. The function is defined by f from r to r is defined by f of x is equal to 1 plus x square. So then solution, again same, follow the same steps. Here given is f from R to R is defined by f of x is equal to 1 plus x square. This 3 marks you chances aithe. So 3 marks or 5 marks. Okay. So f is 1 1. To show that f is 1 1, we have to consider f of x1 is equal to f of x2. Then f of x1 can also be written as f1 plus x1 square is equal to 1 plus x2 square. Here plus 1 get cancelled. We remains with x1 square is equal to x2 square. Don't cancel squares on both sides by taking root. By taking root on both sides, we are going to get the cancel. But don't do that one. It is wrong. Because here x1 and x2 are belongs to R to R. Right? Real numbers of the so take this one to this side. We get x1 square minus x2 square is equal to 0. Or x1 minus x2 into x1 plus x2 is equal to 0. A square minus b square formula apply ಮಾಡಿದೆ. A minus b into a plus b. So therefore x1 is equal to x2 or x1 is equal to minus x2. So that is a x1 is equal to plus or minus x2. So therefore f is not 1 1. ನನಗೆ ಏನು ಬೇಕಾಗಿತ್ತು f of x1 is equal to f of x2. Then we have to get x1 equal to x2. See here, one example I will consider here. Suppose if x1 is equal to minus 1. Yeah, x1 is equal to minus 1. Then f of x1 is equal to 1 plus x1 square. Right? Now put x1 equal to minus 1 here. Put x1 equal to minus 1. We get here 1 plus minus 1 square. That is 1 plus 1 is 2. Right? So what about x2? Now consider x2 is equal to plus 1. Then f of x2 is defined as 1 plus x2 square. Right? So now put x2 is equal to 1. So 1 plus 1 square. 1 plus 1 is 2. Right? Here we have f of x1 and f of x2 value is 2. Right? Here both the values are 2. But what about x1 minus 1? What about x2 plus 1? Whether these two are equal? No. Both are not equal. So therefore it is not a 1 1. It is not a 1 1. Right? Similarly, f is onto. What is f is onto definition? We have to consider let y is equal to f of x. Then y is equal to 1 plus x square, because f of x is given, that is 1 plus x square. Right? So solve for x. We get x square is equal to y minus 1. Then x is equal to square root of y minus 1. y ಅಂತಂದ್ರೆ ಏನೈತಿ r, that is real number, but it is under root minus 2. If suppose y belongs to minus 2, y equal to minus 2, we get here minus 3, but root of minus 3 does not belongs to r, right? Because it is a complex number. So therefore does not belongs to r. F is not onto. So here given question ಏನೈತಿ, whether it is 1 1 or onto ಅಂತ ಕೇಳಿದಾರೆ. ಇದು 1 1 ಅಲ್ಲ, onto ಅಲ್ಲ. Note it down. So next question, let f from n to y be a function defined as f of x is equal to 4x plus 3, where y is belongs to natural number. Indirectly they are saying that n to n only. So y is equal to 4x plus 3, and also show that f is invertible, and also find f inverse. Okay, inverse of f. Here solution, given function is f from n to y, but y is defined as a small y is belongs to natural number, such that y is equal to 4x plus 3 for some x is belongs to natural number. Right? So here to show that f is invertible, again we have to show that f is 1 1 and onto. That is f is bijective. If f is bijective, then only inverse going to exist, right? F is 1 1, that is let f of x1 is equal to f of x2, right? What is the f of x1 here? So here f of x is nothing but 4x plus 3, that is 4x1 plus 3 is equal to 4x2 plus 3. Here plus 3 get cancelled, and we remains with 4x1 is equal to 4x2. Again 4 get cancelled, and we have x1 is equal to x2. Here f of x1 equal to f of x2, then we have x1 equal to x2. So therefore f is said to be 1 1. F is 1 1. What about onto? To show that f is onto, again we have to consider y is equal to f of x. That is f of x is given, that is 4x plus 3. That is solve for x1, we get, so y minus 3 is equal to 4x, then x is equal to y minus 3 divided by 4. So which is belongs to n, because y is a natural number, right? So therefore f is onto. If f is onto, since f is 1 1 and f is onto, then we say that f is bijective function. If f is bijective, then f is said to be invertible, right? F is said to be invertible. Either show that f is invertible, so it is proved. Now what do we have to show? We have to find the value of f inverse, right? So to find f inverse, consider y is equal to f of x, then x is equal to f inverse of y, because it is 1 1 and not 2, right? So f inverse of y, and here we know that x value here, that is y minus 3, that is f inverse of y is defined as y minus 3 divided by 4, which is an invertible function. So this is only f inverse. So note it down. 5 marks are important.